Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad IZZAT bin Muhammad NURUDDIN. I am from RY31. So today I will do some demonstration for lab 4, which is for Bode Plot. This demonstration will be use application MATLAB. So without further ado, we'll go for the lab. So in this lab, we will be we need to observe the Bode plot frequency response. So for the procedure 3, we have been given this RLC circuit, and in this RLC circuit have unknown value. So this unknown value need to be filled in with the provided allocation value by Dr. Nazrin. So my allocation for this value will be at below. So after that, we need to put the system inside the RC circuit. So using this MATLAB, will be show you the demo how this will work, and the Bode plot will be come out. So in this lab, we need to obtain gain margin, phase margin, crossover frequency, and the phase over frequency. So K have been provided. So K will be equal to 0.1 per S. After that, using semi-log graph, so manually, which mean we need to prove by calculation. Okay, this is number 4. Also, the use by the allocation value that have been provided, just need to key in and then do some mathematical. Okay, lepas tu describe the understanding, and K will be 100, and the same thing as the procedure 3, but need to replace the K. Okay, this is the calculation that have been calculate before this demonstration. So the value will be 2 Henry, 3 ohm, and 3 farad. So we calculate and get the answer 1 per 9s plus 6s power of 2 plus 1. And then we include the system inside, which is K equal to 0.1, and then we need to multiply it. So we will get 0.1 per 6 power of 3 plus 9 power of 2 plus S. So this is S. So this is the result. So I will demo the result, and this coding, the same coding that used in lab 3. So numerator 0.1, numerator 0.1, and denominator will be 6, 9, 1, and 0. So the value 0 here, no power S. S equal to power 0. So we run this. So make sure the transfer function is same as the equation we calculate here. So we get the Bode plot graph. using MATLAB, so easy to use. So this is the actual value in the simulation. We get is already plotted here, the intersection at the magnitude and the phase. So we get the value here. After that, this is the calculation for the magnitude and phase. But this for the result after we plotting the graph. So we show you calculation for the graph first. For the MATLAB, only this. So put some coding and get the answer. So this is the calculation. We take the equation before, and then we factorize it as, and then we factorize it for to get the bracket one, and then we replace s equal to j omega. So all the s will be j omega, and then for the plotting is compulsory to get the plus 1 here. So in order to get the plus 1, we need to factorize. After that, we divided at the with the 0.1, we got 0.6 point something, but we take 0.6 and then we use this equation to define all the in the magnitude plot graph Bode plot. So we put here 0.6, 20 log 0.6 minus at the numerator will be the plus, and the denominator will be negative, will be minus. So 20 log j omega negative 20 log plus j omega per 0.12808, and 20 log 1 per j omega 1 per 1.379. Okay, for the this one, so for starting we need to plot the 0.108 and then 1.379 and then 0.6. So after that we need to do this barrier, just for the reference. So we'll be starting to do the magnitude and frequency Bode plot. Okay, starting here will be negative 20. After that it will be negative 40, because this is already 20, negative 20. This is plus plus another negative 20, so will be negative 40. So this is the flat 4.4 decibel. So we will be go for the 20 decade, one decade here and another decade here. After that, here is plus 60, because there is 3 line that referring. So plus another negative 20, so will be go down here. So here is the intersection of phase gain, as we can see here in the Bode plot. Here is the graph, the actual graph. It's the same graph, but the calculation one. So here we can see the intersection here is the same. So here will be made the here. Okay, This one will be the phase gain. So the phase gain Bode plot also the same one, but it's different a bit because it need to do some calculation in order to get the value for the plotting. So I will skip the plotting. I will just tell about this green line. So here we get the constant JW, and then will be 0 degree, and then 0 degree plus minus 45 degree here. So we will go down 45 degree at 90, and then here is plus 45 minus 45 will be 0 degree, so it will be constant here. After that plus 45 minus 45 minus 45 will be minus 45 degree, and then also here okay, will be get 90 degree, and then we get to here, so we'll be at the same line. But how do we get the intersection magnitude gain? So as we can see in the simulation, the intersection at the negative 180, so we get the line here, so we draw the line, so we get the intersection here and go up, we get here same like this lah, and okay, that's all for the procedure 3. So we go for procedure 4. Procedure 4 will be same one but without the calculation only. So we need to do we need to put the allocation value inside the calculation, and then we need to multiply it. So we get the base formula, only to need to replace the k. K will be replaced by 100, 50, 500 and 1500. So we get the value here. So we need to put the value 400, 400, 1, 41, 250, 408 and 0. It's power of 4. So we get the Bode plot for this. Okay, this is Bode plot for k equal to 100. So this for the procedure 3, the Bode plot is stable. So also this one will be stable one, because the magnitude graph here meet the intersection first, and then phase degree will meet at the after that. If the magnitude if the phase meet the intersection first and magnitude meet second after that, the graph the system will be unstable and will be oscillate. So after that we need just put this 100, change the value for the numerator 100. So for the procedure 4, we can observe that when we change the value of the numerator, the gain margin will be starting to decrease. Okay, so 1500. I skip the k equal to 500. Okay, 3000. sorry, 3000. Okay, 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 for this k equal to 1500, we can see the margin value decreasing, which mean is not good for the system. Okay, I think that's all for the demonstration. Okay, thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.